Hi, I'm Keaton Hanley. I'm a student working with Dr. Meadows, taking measurements of a military jet engine thrust using lasers. So over the past couple decades, most measurements have been taken with probes. So these look something like this. So the first problem is that it's an intrusive measurement, so that this probe physically protrudes into the flow field and disturbs it. So the probe intrusiveness is sort of analogous to rocks in a river flow, is that the water or the air has to go around the probe, and as a result it completely changes how the flow field behaves. And the other issue is that when we go up to high temperatures, like what we see in modern jet engines, these probes are subject to temperatures in excess of 3,000 degrees Fahrenheit, and so they would just melt, or at the very least yield a really inaccurate result. And so that's why our work is focusing on using lasers to non-intrusively measure this flow. So the technique that we use is called filter Rayleigh scattering. Most people are familiar with Rayleigh scattering because you see it every day. It's the reason why the sky is blue, because it describes how light interacts and scatters off of molecules of gas. So what we're doing here is taking these filter Rayleigh scattering measurements on the aft burning jet rig. It's effectively a laboratory scale military jet engine, like an F-35. So the hot gases that are created by the flame inside the aft burning jet rig exit the nozzle, and these really energetic, high temperature gas molecules encounter the laser light. We collect this using a series of cameras in which we can then use the image intensity and relate that back to the density, temperature, and velocity that we're really interested in measuring. Using all these quantities, we can gain a ton of insight of how the rig is operating, and if you pair that with the rig data, it gives us a much more complete picture of how the rig is operating, and it allows us to measure the performance of the rig, whether it be combustion efficiency or thrust. In the future, we see filter Rayleigh scattering be used in a variety of different disruptive applications, whether it be measuring thrust in flight, used as a validation tool for probes, or the replacement of these probes, as well as taking measurements inside engine combustors where temperatures are far too extreme for probes to survive.